All right, this is trigonometry for Physics 2 in the summer of 2020. So I'm going to assume you've never had trigonometry before. It's taught at Integrated Math 2, but not very extensively. So I'm going to start off here assuming you know nothing about trigonometry. You do need it for the Coulomb's Law lesson and possibly for some others in the future. So let's go ahead and do this. It'll be about a 40-minute lesson. Maybe a little shorter, maybe a little longer. So analyzing forces in two dimensions requires trigonometry. All problems in this set will involve right triangles. These are triangles with a 90-degree angle and two other angles. So this is a 90-degree angle. It's just two perpendicular sides like that. All right, the first thing we're going to start off with is not trigonometry, it's basic geometry. So it's the Pythagorean Theorem. So what is the length of side C? So you're trying to find the length of this side, and you're given this side and this side. So the formula is a squared plus b squared equals c squared. It doesn't matter which side you call a and b. It doesn't matter. Either one can be either side. It does matter that the hypotenuse, the longest side, is c. So the way you solve this for c to find that answer is you take the square root of both sides. So the square root of c squared, that's going to give you c. And then the square root of a squared plus b squared. So 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. See that right there? And if you take the square root of 25, you get 5. And so that's the answer that you come up with right there. If you know any two sides of a right triangle, you can solve for the third. So if you'd been given the hypotenuse and this side, and you were trying to find this side, you didn't know this side, you could do that. So any two sides, and you will be able to find the third. It's got to be a right triangle. All right, so there are a couple of other principles of geometry you need to know for this lesson, so let me just run these past you quickly. Vertical angles and similar triangles. So two angles on opposite sides of intersecting lines are called vertical angles. Vertical angles are equal. In the example below, if the angle on the left is 34 degrees, this one right here, then the angle on the right is 34 degrees. And whatever the measure of this angle is right here, and you could figure it out, but we're not going to do it, is going to be the same as the measure of that angle right there. Those are called vertical angles, and they are going to be equal. So you'll see that come up in the Coulomb's Law problem. All right, the other thing is similar triangles. Similar triangles are triangles of different sizes, but they have the same angles. So in these two triangles right here, they are similar triangles. So this angle, these two angles you can see are vertical angles right there, and they're the same. And then these are 90-degree angles if they're right triangles. Those two are the same. And if those two are the same and those two are the same, then these two have to be the same because they have to add up to 180 degrees in a triangle. All right, so that's it as far as the basic geometry. Now we'll move on and deal with the trigonometry. Okay, so trigonometry gives us a way to find the lengths of the sides of a right triangle if we know the length of one side and the measure of one angle besides the 90-degree angle. So what we just did a moment ago, if you knew two sides, you could figure out the third. In this case, if you know one side and one of the angles aside from the 90-degree angle, you can also figure out the lengths of all the sides. Angles in trigonometry are usually assigned the Greek letter theta. It looks like a 0 with a line through the middle of it. The side farthest from theta is called the opposite. So there's theta. So this side over here is called the opposite. We abbreviated OPP. There are two sides that are next to theta, these two sides right here. The longest side is called the hypotenuse. That's always the longest side of a triangle, and that's abbreviated HYP. The other side next to theta is called the adjacent. The word adjacent means next to. So you have adjacent, hypotenuse, and opposite. So here are the relationships that trigonometry uses. And you should just write these down so they're in front of your eyes the whole time that you're doing any of these problems. The sine of theta equals the opposite over the hypotenuse. So whatever this value is divided by this value, that's the definition of the sine of theta. The cosine of theta is defined as the adjacent over the hypotenuse. So if you took this side over this side, that fraction, that would be the cosine of theta. And the tangent of theta is the opposite over the adjacent. So that over that would give you the tangent of theta. And there's some mnemonics. Those are just memory devices that some teachers use. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, and tangent, opposite adjacent. Okay? But you don't have to memorize those. You can have any notes that you want in front of you. All right, so let's go ahead and try a problem here. So finding a side from an angle and a side. So here you have one known side. You have two that are unknown, but you do know the angle. So what we're going to do first is we're going to find the opposite. So how do you find that? Well, you remember that the relationship is the opposite over this number, 12, is going to equal the sine of 32 degrees. So sine of theta equals opposite over hypotenuse. Sine of 32, that's theta, that's your angle, equals opposite over, and there's the value of the hypotenuse is 12. So sine of 32 equals opposite over hypotenuse. Now there's a little algebra step you have to do here. Some of you may not be that great at algebra, so I'll show it to you, and you'll see it a lot of times. So if I rewrite that over here, sine of 32 equals the opposite side over 12. Now I want to solve for this. And what that means, that term solve for, means I want to get this all by itself on one side of the equal sign. That means I need to get rid of the 12. I got to get it out of there. So the way I do that is I multiply both sides by 12. An equation, a math equation, is like a scale. And there's the middle of the scale right there, the equal sign. And you can keep it in balance by, if you do something to one side, you have to do the exact same thing to the other side. Right there. So on this side, the 12's cancel. So now you'll see opposite is all by itself right now. Okay, so there you see it down there. What I have here is right there. So now what you have to do is you have to multiply 12 times the sine of 32. I'm going to show you how to do that on a TI-30. That's the kind of the standard calculator that a lot of schools have. This is where I don't know if you can use your cell phone for this. You might need a calculator for this. So we'll go ahead and do this. I'll hope that you have a calculator like this. All right. So what I'm going to do is it's going to glare a little bit, but I'm going to go ahead and do this on the screen as best I can. So it's 12 times. So I push 12 times, and then sine. There's the sine button right there, and 32. And now remember to close the parenthesis. And so now I have that equation. I hit enter or equal, and it gives us we'll call it 6.35, 6.36. Okay. So the opposite is 6.36. Now you got to be careful that your calculator, it's very hard to see this. It says DEG, that it's set for degrees. There are two other measures that are used in trigonometry. One is radians. That's used fairly often in a trigonometry class. The other is called gradians. Oh, that's never used. But you got to be sure it does say DEG or that it's set for degrees. Here's one way to test real quick. Do sine of 30. That should come out to be 1/2 or 0.5. And there it is, 0.5. If it doesn't, it comes out to be something other than that, then you don't have it set in degrees. Okay, so that's one way to test if you're not sure. Okay, we're going to go ahead and do find the adjacent side now. Okay, just to finish up that last part of the problem, press the sine key on the calculator, then enter 32. That was the last thing that we just did. I actually wrote out what the sine of 32 degrees is. It's there right there, but you don't have to do that. You can just go 12 times sine 32 as we did, and you came out with 6.36 as your answer. That was the side of the opposite. Okay, let's go ahead and do the adjacent now. So to find the adjacent is equal to adjacent over hypotenuse is the cosine. That's the definition of cosine. It's the adjacent over the hypotenuse. So if we come down here, cosine of theta equals adjacent over hypotenuse. So cosine of 32, that's our angle, is adjacent over 12. The unknown adjacent over 12. So now it's very similar to the last problem. We multiply both sides by 12. So I'll do that real lightly here. 12 on that side, 12 on that side. These two cancel out, and you have 12 times cosine 32. There it is right there. So we'll go ahead and plug that into the calculator. Try to keep the glare off. So 12 times cosine button right there, 32, close the parenthesis, and that equals and that gives you 10.2. So the adjacent right here equals 10.2, whatever we're measuring in, centimeters, inches, whatever you happen to be measuring in. Okay, that I did it down here again. I punched out the cosine of 32 and wrote it out, but you don't have to do that. So that would be the cosine of 32, and that gives you 10.18. I wrote 10.2, same thing. Okay. All right, let's keep pushing on. Now, we're going to go in the other direction now. And this is going backwards from what we just did. So you're finding an angle from two sides, and that's called an inverse or an arc function. So it could be called an arc sine, an arc tangent, an arc cosine, or an inverse tangent, an inverse cosine. So we can find an angle from two sides using an inverse or arc, sine, cosine, or tangent. This is done on a calculator using the second function and pressing sine, cosine, or tangent. So let me just show you that real quick. If I come up here, and what this second button is, this light blue button, is it activates all of these functions that are up above the keys. So those are called the secondary functions. Okay, and so if we wanted to do the inverse sine, we would hit second, and then we hit sine, and there you can see that's the way you would show an inverse sine, sine to the minus 1. So that's, again, either called arc sine or inverse sine. Okay, so I've given you a problem here where you have all three sides. You don't really need to be given all three sides. I'm going to have you work some problems where you're only given two. But you have to be given at least two sides, and from that you can work backwards and find theta. Okay, so there are several ways to do this. You can choose the one you want. So using inverse tangent, so I'm going to choose to go ahead and use inverse tangent. We know that tangent of theta equals opposite over adjacent. So that equals tangent of theta equals 5, this number, over 12, this number. Now what we need to do is we need to get this theta outside of that tangent. We want to know what theta is. We don't want to know tan theta, we want to know theta. So what you do is you use the inverse function. So now you undo the tangent by taking its inverse, just like division is the inverse of multiplication or square root is the inverse of a square. Let me just give you a quick numeric example here. So if I take the number 3 and I multiply it by 4, that equals 12. So the inverse of multiplication is division. So if I divide 12 by 4, it takes me back to 3, where I started. So the multiplication and division undo each other. If I take 3 and I square it, that gives me 9. If I then take the square root of 9, that equals 3. So the square and the square root function, undo each other. Similarly, the tangent and the inverse tangent undo each other, just like that. So if I start off with theta, and I take the tangent of theta, and then I take the inverse of the tangent of theta, that'll lead me back to theta. Just like 3 led me back to 3 here, and 3 led me back to 3 there. Okay? So I take the inverse of this to get theta, but now I also take the inverse on this side. Anything you do to one side, you have to do to the other. All right? So what we have then is we have theta equals tan minus 1 inverse tangent times 5, or 5 over 12, 5/12. Okay, so we do that on our calculator now, and that'll give us the angle theta. So here we go. So it's second tangent 5 divided by 12, close the parenthesis, and hit equal. And that gives us 22.6. So that means this angle right here is equal to 22.6 degrees. Okay, so by using two sides, we were able to work backwards using the inverse function to get the angle. Okay, and here I describe that process. On the TI-30 calculator, you press second and then tangent. This gives you the inverse tangent. Then you press 5 divided by 12. And then you close the parenthesis and then press enter. And that will give you the angle 22.6. Now you could have done that another way. You could have used the sine or the cosine. Let's do it using the inverse sine. So if we look at this, the sine is opposite over hypotenuse. So if we take the inverse of 5 over 13, that's the sine. If we take the inverse of that, that'll give us, it will give us the same angle. It's just a different way to do it. I'm just showing you there isn't just one way to do this. So sine equals opposite over hypotenuse. That was 5 over 13 that you just saw. And so let's take the inverse of that. So you take sine of theta, you take the inverse of that, and that gives you theta. So you take the inverse sine of 5 over 13. So let's go ahead and do that and practice this again. So second sine, and then it's 5 divided by 1/3. Close the parenthesis, hit that, and you get exactly the same answer, and that's 22.6. Okay, and you could have done it with the cosine just as well. All right, so that's the two types of trigonometry problems you need to know how to do. I'm going to give you 7 examples. None of this is required, but you should do these, as many of these as you feel you need to get this concept down. All right, so I'm going to go ahead, and the first 4 are going to be where I give you an angle and I give you one side, and then I ask you to find the other 2 unknown sides. That's the first 4. The last 3 are going to be, show this to you, where I give you 2 sides and you figure out the angle theta and the unknown side. All right, so let's go ahead and knock these out. Do as many as you feel like you need to do. That'll be our lesson on trigonometry. Okay, so here we go. So we want to find the hypotenuse. We want to find this. Okay, so we know that opposite, that's the one number that we were given. Opposite over hypotenuse is sine. So sine of this angle, 28, equals 8 over the hypotenuse. And we're trying to find hypotenuse. Now, unfortunately, when this is in the denominator, it's a 2-step algebra process, okay? So what I'm going to do is multiply this side by hypotenuse. I'll multiply this side. Didn't give myself a lot of room here. Multiply that side by hypotenuse. This cancels. So now I'll rewrite it down here. I have hypotenuse times sine of 28. And that equals 8. Everything canceled here except the 8. Now I need to get this by itself. When we say we're solving for a variable, it means you're trying to get that variable by itself on one side of the equation, so then you can then just process all the numbers, just use arithmetic to process all the numbers to get that number. So we need to get rid of the sine 28. So we do that by dividing. Cancel, cancel. So now we have hypotenuse equals 8 over sine 28. And we're ready to go ahead and pull up our calculator here and find the hypotenuse. So here we go. So hypotenuse equals 8 divided by sine 28. Close the parenthesis. I put 25. That's not good. 28. Close the parenthesis. And there we go. 17. Okay, so the hypotenuse is 17. 17.04, we'll just call that 17. All right, now we're going to find the adjacent. Now that we have these two, we could use the Pythagorean Theorem to do this, but we're not here to practice that. We're here to practice the trigonometry. So let's go ahead and do that. So what could we do? Well, we could say adjacent over hypotenuse is the cosine. Again, keep those definitions, those 3 definitions of what cosine, sine, and tangent are. Keep those in front of you all the time. So I'll go ahead and write that out. So the cosine of 28 degrees equals the adjacent, which is what we don't know, what we're trying to find, over the hypotenuse, and that's 17. Okay, so this is just one algebra step. You need to get adjacent by itself, so you multiply by 17 to cancel, but then you have to multiply this side by 17 as well. So that means adjacent is going to equal 17 times the cosine of 28. Okay, so let's go ahead and do that. 17 times cosine 28, close the parenthesis, and you get 15. Just call it 15. and that equals that. Okay, so there you have all three sides there. Okay, let's move on to the next one. In this one, we're given the adjacent and the angle, and we need to find these two. So first we're going to find the hypotenuse. So what we're going to do is adjacent over hypotenuse equals the cosine of this angle. So the cosine of 40 equals, again, the definition is the adjacent over the hypotenuse. We know the adjacent, we don't know the hypotenuse. All right, now we got to get the hypotenuse by itself. So first we multiply both sides by the hypotenuse. What that does is it gets it off the bottom and puts it up on the top over on this side. Okay, now we just have an 11 left on this side. So now we have to divide both sides by cosine of 40. Cancel and cancel. And what you have is, I'll write it up here, hypotenuse equals 11 over cosine of 40 degrees. Okay, so on the calculator, from here, we have 11 divided by cosine 40, close the parenthesis, and you get 14.4. So the hypotenuse is 14.4. And that makes sense. It's a little bit longer than the adjacent. This adjacent's a pretty long side, but the hypotenuse has always got to be greater than that. Okay, it's got to be greater than this as well. Okay, let's go ahead and figure out the opposite. So the cosine of 40. So what do we want to use? Let's use, it doesn't really matter. Let's go ahead and use opposite over adjacent. That would be tangent. So let's do that one. Opposite over adjacent is the tangent. So the tangent of our angle 40 equals opposite over 11. So we know 11. We're going to put the opposite there. Okay, this is one algebra step here, so it's a little easier. So now we need to get opposite by itself. So we have to get rid of the 11. So you multiply the top by 11, and it cancels. That means you have to multiply this side on the top by 11. You don't see a top and bottom here, but if you don't see a top and bottom, that's the top. Okay, so that means that opposite is equal to 11 times tangent 40 degrees. All right, so let's do that on the calculator. 11 times tangent 40, close the parenthesis, and there we go. And that gives you 9.2, we'll call it. So this equals 9.2. Okay, and you can see that this is shorter than this, and this is shorter than that, and that's the way that should all work. All right, so the last two problems on this page I'm going to do quietly, and then we'll go over them as soon as I'm finished. You can pause if you'd like and do them on your own. And I'm going to go ahead and just do them silently here. Okay, let's go. All right. Okay, so we had two triangles just coincidentally had the same angle. It doesn't matter, just you get the practice all the same. All right, so you started off with the first one. We were trying to find the opposite. We knew the hypotenuse. Opposite over hypotenuse is the definition of a sine. So the sine of 18 degrees is going to equal this unknown opposite over 15. Multiply both sides by 15 and you get that. That's what you plug into the equation, 15 times sine 18, and that came out with 4.64. Next, you had to do the adjacent. Do it pretty much the same way, except adjacent over hypotenuse is the definition of a cosine. So you take cosine of 18 equals adjacent divided by 15. Multiply both sides by 15 again. You get adjacent equals 15 times cosine of 18. And put that in the calculator and you end up with 14.3. Is that reasonable? Yeah. This is a little bit shorter than this. It has to be. And this is a lot shorter than both of them. So at 18 degrees means the triangle is probably more like this. It's not quite as wide as this is showing. It's really a lot shorter side on this side, and these two are pretty close to the same length. Okay, next, hypotenuse on this one. So you're given an opposite. So, and we want to find this. So opposite over hypotenuse is the definition of a sine. So we use the sine function of 18 degrees. Sine of 18 equals 9 over hypotenuse. Now this is one where you have to use two steps for algebra. Multiply both sides by hypotenuse, and this cancels. Then you got to get hypotenuse by itself. So you divide both sides by sine, or you divide both sides by sine 18. These two cancel, and it ends up on the bottom over there. So this is what you end up with, 9 over sine 18. You plug that into the computer and into the calculator, and it gives you 29.1. And then finally, we're going to figure out the adjacent. So the adjacent over the hypotenuse is the definition of cosine. So cosine of 18 equals adjacent unknown over 29.1. We just figured out that, so let's use that. Multiply both sides by 29.1, and it cancels here. Comes over here. That's the equation you put into the calculator, and that's your answer. Again, 18 degrees is, if I were to draw it, it's really more like this. So this side is really short, and these two sides are fairly close to being the same length, but the hypotenuse has to be longer. So you have these two, which are pretty close in length, but the hypotenuse is longer, and then this one's much shorter. All right, so that's how you do this. Now we're going to move on, and we're going to do some where you're going in the other direction. I'm going to give you two sides, and you figure out the angle, and then you figure out the missing side. Okay, so here we go. Use the inverse functions to find theta and the missing side. Well, one comment about this, to find the missing side, you don't even need to use trigonometry. You could use the Pythagorean Theorem. 12 squared plus 9 squared, you add those two numbers together, you take the square root, and that would be the hypotenuse. But we're here to practice trigonometry, so we're going to go ahead and do it the trigonometric way. All right, so we need to find theta. So what's the relationship between these two? Well, we know that opposite over adjacent is the definition of a tangent. So we can write this. Tangent theta equals 9 over 12. That's simply the definition of the tangent. Okay, well, what we're trying to get to is theta. And theta is wrapped up inside of this tangent right now. We want to get it out. So we use the inverse function to unwrap it. So what you're going to write over here is tangent inverse times tangent theta. And this undoes that, so it just becomes theta. Again, it's like you multiply by a number and then you divide by that same number, you get back to where you started. You start with theta, you take the tangent of theta, and then you take the inverse tangent of that, and you get back to theta again. And that means over on this side, you're going to have the inverse tangent of 9 over 12. Okay, so now we can just plug that into the calculator. And we get, so here's what we do. It's second. Now you don't see anything happen except you see a little second down there at the bottom, but you don't see anything else. Now when you hit tangent, now you see the tan minus 1. And it's 9 divided by 12, close the parenthesis, and hit equal. And 36 point, round it up to 9, 36.9. So that's the angle here. 36.9 degrees. All right. Now we want to get the hypotenuse. So we can use either sine or cosine here. I'll go ahead and use the cosine. So it's adjacent over hypotenuse is equal to the cosine of 36.9. So this is really just like doing the problems on the previous page. Whoops. And we know the adjacent, so I should have written the number. It's that number right there. It's 12. But we don't know the hypotenuse, so I got to write hype. Again, this is two-step algebra problem, so we're going to multiply top by hypotenuse. They cancel. I got to do the same thing on this side. Okay, now I have to get this by itself, so I have to get rid of this. You do that by dividing both sides by that. And you end up with cancel, hypotenuse equals 12 over cosine 36.9. So let's just write that a little more cleanly here. All right, so we plug that in the calculator, so it's going to be 12 divided by cosine 36.9. There it is. And it's 15. Okay, so we're just going to go ahead, and that's going to be 15. And you notice if you divide each of these numbers by 3, you get 3, 4, 5. It's a 3, 4, 5. It's one of the very rare triangles that actually has nice integer values without any decimal places or things on them. All right, let's go ahead and do the next one here. All right, so we need to find this. And we're given two sides, the opposite and the hypotenuse. So opposite over hypotenuse is sine. So the sine of whatever that angle is 7 over 18. Now we're ready to unwrap this. So we're going to take the inverse of sine to get this out of there. And anything you do to one side, you have to do to the other. So we're going to take the inverse sine of the other side. Okay, and I'm going to write it over here. I have a little more space. That becomes just theta. And this is what it is. So that's what we put in the calculator. So it's second sine 7 divided by 18, close the parentheses, and you get 22.9. So the angle here is 22.9 degrees. Okay, now we're asked to find the adjacent. So we can say adjacent over hypotenuse is the cosine of that angle. That's the definition of cosine. Multiply both sides by 18. And that length is going to be 18 times cosine of 22.9. Okay, so that's what we're going to put in the calculator. And that gives us 16.6. Okay, 16.6, a little bit less than 18, a lot more than 7. Again, 22 is kind of a tight angle, so this side's going to be really short compared to this side or this side. These are not drawn to scale. Okay, the last one I'm going to do silently, and we'll talk about it when I get done. You can pause and go ahead and try that on your own. Okay, and you see actually the same sides we had up on this one at the top. It's off screen a little bit, but it's a 3, 4, 5. These are all the ratio, 3 to 4 to 5. Okay, that's this. So what we did was we originally had an adjacent and a hypotenuse. Adjacent over hypotenuse is the definition of cosine. So that means this over this was the cosine of that unknown angle. Cosine theta equals 12 over 15. You unwrap the theta by taking the inverse. That gives you theta. And you do the same thing on this side. Inverse cosine 12 over 15. And that ended up giving you 36.9 as the angle. And then finally you just wrapped it up the opposite. You're just trying to find the opposite. So opposite over hypotenuse is going to be the sine. That's the definition of sine. So sine of 36.9, this angle is opposite over 15. Multiply both sides by 15. You plug that into the equation, and that's it. Okay, so hopefully that was a helpful introduction to trigonometry for you. I don't know how much you're going to have to use it during this unit. I have not seen all the lessons. There just hasn't been enough time to look them all. I'm going to view them as quickly as I can. But hopefully that helped you. That will definitely is something you're going to need to know for this Coulomb's Law lesson, the second lesson of the class. All right. Have a good day.